we now understand and appreciate drawing Lewis structures as an important principle, if you like, an important skill which allows us to understand bonding in chemical reactions. Now, what I would like to illustrate now is another method by which we can draw Lewis structures. Let's take, for example, carbon dioxide. So that's carbon dioxide. Usually before, we calculate the total number of valence electrons, taking into account the number of valence electrons that each atom contributes. Now, the method we are about to learn is slightly different. So the first step is not calculating the total number of valence electrons, but rather calculating the total number of electrons, assuming that all atoms obey the octet rule. So the total number of electrons, if you assume that carbon obeys the octet rule, then it's surrounded by 8. So 8 from carbon plus 2 oxygens, and it's assuming that both of them obey the octet, so 8 electrons from each of them, the total number of electrons would now be 24. So 24 electrons total. The next step would be to calculate the number of valence electrons following the same practice that you've seen before. So the valence electrons will be, in this case, 4 from carbon, because carbon is located in group 4A, and 6 from oxygen, because oxygen is located in group 6A. So it has 6 valence electrons. If you add these up, you get 16. So 16 valence electrons total. Next step would be to subtract that number, 16, from the total number of electrons, assuming that all atoms obey the octet rule. If we subtract 16 from 24, we get a number of 8. So this is 8 electrons, and these are the bonding electrons. So the number of bonding electrons is 8. If you divide 8 by 2, we get the number of bonds possible. That's because 2 electrons are required, obviously, to make a bond. So we divide the number of bonding electrons by 2 in order to get the number of bonds possible in this compound, or in the Lewis structure to be drawn. For that, we begin with the central atom, which is carbon. So that's carbon, and the surrounding oxygen atoms, like that. And then you draw a bond between carbon and oxygen. Now we know that there are 4 bonds, so we can't go wrong with that, okay? Now, carbon must obey the octet rule. Oxygen must obey the octet rule. With this, that's not really satisfactory, because if we draw a single bond between carbon and oxygen, we have to draw 6 non-bonding electrons. Yes, that's okay with oxygen because it's surrounded by 8, but carbon would not be satisfied because it would not obey the octet rule. So we have to draw a double bond, therefore, between oxygen and carbon, and also another double bond between carbon and oxygen. Why do we do that? Because we know that there are 4 bonds. So 2 here, if you like, and 2 here. That's 4. Now what we need to do next is to satisfy the octet rule on each of these surrounding oxygen atoms. So 4 here, 6 and 8. So that oxygen has satisfied the octet. This oxygen has also now satisfied the octet. Each of these surrounding oxygen atoms is surrounded by 8 electrons. So 8 electrons plus 8, that's 16. So that's 16 valence electrons. So this is satisfactory. If you look at carbon, it is surrounded by 8 electrons. So this is good according to the valency rules. Again, to double check, each of these oxygens is surrounded by 8. So that's according to the octet rule. And the central carbon atom is surrounded by 8. There are 16 valence electrons used up in this Lewis structure, and that's good because we had 16 before. There are 4 bonds, and that's in accordance with the information that we have found before. The overall arrangement of electron pairs around the central carbon atom is actually linear, and the molecular shape is also linear. Not only that, the bond angle is also 180 degrees as a result, because the molecular shape around carbon is linear. So The advantage of this method is it allows us to predict exactly the number of bonds possible in the structure for which a lowest structure to be drawn, and thus taken into account the total number of electrons, assuming that all atoms obey the octet rule. And from that number we subtract the number of valence electrons, and then we divide that number of bonding electrons by 2 in order to get the number of bonds possible.